I'm Stacy, your test prep tutor for the Percentages and Ratios unit, which covers a range of topics relating to fractions, percentages, part-to-whole ratios, and more. When was the last time you had a conversation with ratios? Been a while? Don't worry, I'll reintroduce you. It'll be just like chatting with an old friend. In this lesson, we'll go over solving part-to-part ratios. Let's start out with a quick review of some terms. A ratio is a comparison of two different values. Ratios are usually expressed as fractions or by using colons. For example, the amount of air in a bag of chips compared to the amount of actual chips in the bag can be expressed as a fraction or with a colon. Either way, it feels a bit skimpy sometimes, doesn't it? Ratios work in two ways, relating parts to each other, like air to chips, and relating parts to a whole, like chips to the bag or air to the bag. Let's put away the chips and move on to something a little easier to count. Let's look at these 5 pieces of candy. Part-to-part ratios show how individual parts relate to each other. In this case, 3 blue candies and 2 orange candies can be expressed as the ratio 3:2. Part-to-whole ratios show how the individual parts relate to the whole. So 3 blue candies out of 5 candies total means that the ratio here is 3:5. You know you're working with a ratio problem anytime you see ratios written out in this way, or anytime you're specifically asked for the ratio of any two things. Now let's go through an example together. The following question is similar to what you can expect to see on the SAT. A recipe requires that the amount of flour and sugar used follow a ratio of 2:3. If 1 1/4 cups of flour are used, how many cups of sugar should be used? Notice how there are no answer choices given? This is an example of a grid-in problem, where you'll need to bubble in the answer. Don't worry, we'll talk about that in more detail in a little bit. We know that this is a ratio problem because we've been given the ratio of 2:3. Another tip that this is a ratio problem is that the problem gives us 3 different numbers and 2 different units of measure. So we want to start by underlining the facts. In this case, flour and sugar, 2:3, and 1 1/4 cups flour. And by circling the key terms, how many, cups, and sugar. Our problem gives us the ratio in the form of 2:3, but since ratios are often easier to work with as fractions, we want to turn 2:3 into 2 cups of flour over 3 cups of sugar. Always label the numerator and denominator with units of measure to avoid errors. All right, now that we understand our problem and have our ratio converted, let's get to solving. We solve ratios by finding equivalent fractions, and we always put the same units of measure across from each other in the equation. So 1 1/4 cups of flour goes in the numerator across from 2 cups of flour, and x cups of sugar goes in the denominator across from 3 cups of sugar. Now all we need to do is cross-multiply and solve for x. But before we do that, let's pause for a moment and look at the 1 1/4 cups of flour. 1 1/4 is a mixed fraction, and this is a grid-in question. The SAT doesn't allow us to answer grid-in questions with mixed fractions, so let's convert it to an improper fraction, also known as a fraction whose numerator is greater than or equal to its denominator. In this case, 1 1/4 becomes 4/4 because with 1, we have 4 quarters plus 1/4, which equals 5 quarters. Okay, now that we've gotten rid of the mixed fraction, let's enter 5 quarters in our ratio and get back to the question. We'll cross-multiply over the equal sign and drop the units of measure to get 2x equals 15/4. Now we want to isolate x, so we'll divide both sides by 2, which is mathematically the same thing as multiplying both sides by 1/2. And that gives us x equals 15/8. That means if we use 1 1/4 cups of flour, we'll need 15/8 cups of sugar. The final step? Check to make sure that we answered the question that was asked. How many cups of sugar should be used? Great. We solved for the amount of sugar and found that we need 15/8 cups of sugar. All that's left is to fill in the answer grid. Because this is already an improper fraction, it's ready to be entered into the grid-in and bubbled in. Write your answer in the grid and then fill in the corresponding bubbles below using the fraction slash bubble. Great work! By recognizing that we were dealing with a ratio problem, then setting up our fraction equal to fraction equation, we approached this problem strategically and solved for the answer correctly. But what if you aren't comfortable working with fractions? Well, first you should continue practicing. The more comfortable you get with them, the easier this test and other parts of life will be. Second, remember that if you don't like working with fractions, you can always convert them to decimals.